Hello everyone, welcome back to the map of mathematics. In this video, we are going to solve this nice math Olympiad algebraic challenge, and here we have a plus 3 whole cubed plus a plus 5 whole cubed equals to 8, and here we find the value of a when our a belongs to R. So this means that we can solve this problem for the real values of a. So the very first thing we are going to do is here first we rewrite this given equation as, here we have a plus 3 and we write it as a plus 4 minus 1. We write this 3 as 4 minus 1 because 4 minus 1 equals to 3, and similarly we write this 5 as a plus 4 plus 1, and you know that 4 plus 1 becomes 5. So this is the whole cube of this one and whole cube of this one, and this is equals to 8. And now in the next step we will convert this nice equation into simplified form, so that here we will take y equals to a plus 4. So you see that we have a plus 4 in both of these terms, so we take it equals to y, and this expression will becomes y minus 1 cubed plus y plus 1 cubed equals to 8. So here we need the cubic formula, so that in order to use the cubic formula, first we write it here. We know that if we have a plus b whole cubed, it is equals to a cubed plus b cubed plus 3 times of ab into a plus b. So this is the positive, and if we have the negative cubic formula, so then you can just place the negative sign on each of these plus sign. Okay, so now we use these two formulas on the above expression. So our above expression will be written as y cubed minus 1 cubed minus 3 times of y into 1 and into y minus 1, and we have plus y plus 1 cubed equals to uh, y cubed plus 1 cubed plus 3 times of y into 1 into y plus 1, and this whole equation equals to 8. So now here we use both of these cubic formulas, and now we can just simplify the terms. And now you see that we have, this is y cubed and y cubed becomes 2 times of y cubed. This is negative minus 1 cube and plus 1 cube are gone by each other, and here we multiply this minus 3y on both of these terms and this plus 3y on both of these terms. So it will becomes minus 3 times of y square plus 3y, and from this we have 3 times of y square plus 3y, and this whole equals to 8. So again you see that here we have this minus 3 times of y square and plus 3 times of y square are also cancelled by each other, and we obtain here 2 times of y cubed plus 3 times of, this is 3 times of y plus 3 times of y will become 6 times of y, and we move this 8 in the left hand side and it will becomes minus 8, and this whole equals to 0. So now in the next step we will just divide each side by 2, and we can obtain here y cubed plus 3y minus 4 equals to 0. So here we get this cubic equation, and now here we easily make the factors of this cubic equation. So here we first break its middle term, and further we can simplify it and we can easily make the factors of this cubic equation. So we have y cubed, and here you have plus 3y, and we can break this 3y as minus y plus 4y. So minus y plus 4y becomes 3y, and here we have minus 4, and this whole equation equals to 0. So now from first two terms we take common y, and it will becomes y square minus 1, and from the last two terms we take common 4, and it will becomes y minus 1 and this whole equals to 0. So now in the next step, we use the nice algebraic identity, and you know that if we have a square minus b square, it is equals to a minus b times of a plus b. So we use this algebraic identity here, and we get y minus 1 times of y plus 1 and plus 4 times of y minus 1, and this whole equation equals to 0. So now in the next step, we will take common y minus 1 from both of these terms, and we will take common y minus 1 times of y into y plus 1, and here you get plus 4, and this whole equation equals to 0. And now in the next step, we have two cases here. So our first case is we take y minus 1 equals to 0, and the second case is we take the other term or other factor equals to 0. So it will become y times of y plus 1 plus 4 equals to 0. So in the first case, we easily get the value of y equals to 1, and here we back substitute the value of y, because in the start of the problem we will take here our y equals to a plus 4. So we have a plus 4 equals to 1, so you get the value of a equals to 1 minus 4, and finally we have a equals to minus 3. So this is the first real root of this problem, and now we find the other real roots. Now we can find or simplify or solve this equation. So first we multiply this y on both of these terms, and we get y square plus y plus 4 equals to 0. So this equation will becomes a quadratic equation in y variable. So now first we check that is this quadratic equation has real roots or not, by using the discriminant formula. So according to discriminant, first we need the coefficients of this equation, and we have a equals to 1, b equals to 1, and c equals to 4. So our discriminant formula will be written as delta equals to b square minus 4 times of ac. So we put the values of a, b, and c here, and we see that this is 1 square minus 4 times of 1 into 4, and 1 square equals to 1 minus 4 times of 4, it becomes 16, and 1 minus 16 equals to minus 15. So you see that our delta is less than 0. So by the definition of discriminant, if our this delta is less than 0, it means that this equation has no real root. So if this equation has no real roots, so we rejected this case, because in this question we need only real roots. So we rejected this case, and we have only one real root, which is a equals to minus 3, and this is the final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.